Alright, so we got one more example here in how we're going to use the second or maybe the first derivative test. So we want to find all the possible local extrema of this particular function g of x. We want to use the second derivative. So let's start by finding the first derivative. G prime is equal to 4 times x minus 1 to the third power. Then we want to set this equal to 0 and solve for x. Since we do want to determine where f or g prime is equal to 0, we need to find some critical points first. So solving this isn't too hard. We get that x is equal to exactly 1. So we could probably make a sign chart here of g prime and see what that looks like. But we're asked to use the second derivative test as some practice. So let's take g double prime and use that and test our concavity. So we take g double prime, we will get 12 times x minus 1 to the quantity second power here. Now we want to know, well, what is g double prime of 1? Well, sadly, g double prime of 1 is equal to 0. So the second derivative test tells us nothing here. We don't know if g is concave up or down here at this point. Okay, we don't know if g is concave up or concave down at x equals 1. So the second derivative test does not work in this case. Well, so what are we to do except to return to the first derivative test? And now we can just plug in some numbers and check it out. Plug in some numbers that's less than 1. So 0, that will give you negative 1 square cubed times 4. That's a negative number. Plug in some number here that's bigger than 1. That will result in a positive result. So we know that at so this is going to be a min, since g is going to be decreasing and then increasing. And let's figure out g of 1 is equal to 0. So we can say that g of, or the function g of x has a local min at 1, 0. Okay. And when you really think about it, it's not too difficult to figure out. This function is just x to the fourth translated 1 to the right. So it would look something like this. It'd probably be a little bit more level off than a quadratic function. So here you have a local min, and in fact it turns out to be an absolute min. But in this case, this is one of the examples that we see the some of the weaknesses of the second derivative test is that if the second derivative turns out to be 0, you don't know anything about the concavity, and you're left to rely on the first derivative test. So the first derivative test is most of the time superior, except when it's really difficult or tedious for us to figure out some sign charts. So on the cases where we can take the second derivative quite easily, it's recommended that you do so. Otherwise, you stick with the first derivative test. As always, ask for questions if you need it. Thank you for watching, and have a wonderful day.